calculate the CAPM returns of X. Calculate the CAPM returns of security X. This is something that I should be able to get really very easily. I don't need to hustle at all. I don't need to hustle at all to be able to get these particular CAPM returns, because what a good student first of all will do is to write the CAPM equation. Could you kindly write for us the CAPM equation? Write the CAPM equation. So CAPM equation here, what do we have on the CAPM equation? Our CAPM equation, our CAPM returns of X will be equal to, we must always begin with risk-free rate of return. Risk-free rate of return plus, of course, we have here ERM minus risk-free, ERM minus risk-free, minus risk-free, minus risk-free, multiplied by beta of X, multiplied by beta of X. So they want us to calculate the CAPM returns of X. So I'll first of all start by writing the CAPM equation. We start first of all by writing the CAPM equation. So our CAPM equation, CAPM returns of X equals risk-free plus, into brackets here, ERM minus risk-free, multiplied by what here, beta X, multiplied by beta X like that. Ladies and gentlemen, could you kindly be nice to Mwalimu here today? This kind of a question, where do you think are we going to start from? Where are our low-hanging fruits? Is there anybody who is able to see where I should be able to harvest my low-hanging fruits from? Where are my low-hanging fruits? 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 Yes, we need first of all to calculate, because there is no way we can work with dancing returns. We would want first of all to calculate the average returns. So we need the expected returns of the security X or portfolio X, and then we need the expected return of the market. Great, thank you so much. So we need here the expected returns of X. So in this case here, what do we do? Of course, I know for expected return of X, I will take ta plus ta plus ta. But you see now there is no ta. There are no probabilities. No probabilities. So then what should I do? Sharon is giving us an important formula there. Sharon is giving us an important formula there. Sharon is telling us that we need to come and talk over, you know, like if, for example, you've got 3 students, and these 3 students here, they give you, for instance, they give you like weights of 3 students, like this is weighing 80 kilograms, another one 60 kilograms, another one in this case here, for example, 30 kilograms. How do you get the average weight? You need to add the 3 weights. You take 80 plus 60 plus 30, and then you divide by 3. Because now we don't have probabilities. So then here, to get expected returns of X, you will come and sum the returns of X, and then you divide by N. Please, Candy, when we are getting expected returns, we don't divide by N minus 1. Whenever we are getting expected returns, we shall only take here the summation of returns here. You divide by exactly who? You divide by N. You divide by N. So summation of Rx, they are here. So we have here 15 plus 8 plus 7 divided by 3. 15 plus 8 plus 7 divided by 3. I'm being told by Elizabeth, this is 10. Ciao. 10. This is 10. On the same breath, could you kindly go ahead and give me expected returns of M? Go ahead and give me expected returns of M. Expected returns of M is 3 plus 7 plus 5. All over what is somebody? All over 3. 3 plus 7 plus 5, all over 3. What we have here, Paul Macau is giving me a figure of what here? A figure of 5. A figure of 5. A figure of 5. Thank you and thank you so much. Thank you and thank you so much. Thank you and thank you so much. Now, ladies and gentlemen, if I'm the one doing this question, I know that the next thing will be for me to get the risk factor. You know, if it's CAPM, you can't work with CAPM without beta. We can't work with CAPM without beta. So the next thing will be for us to get beta X. So the next thing will be for us to get beta X. So what I do not know is whether we have any student who will be able to give us this beta X value. Is there any student who will be able to give us this beta X value? Do we have any student here who will be able to, not even the value, but basically the formula? Beta x will be equal to, beta x will be equal to who? So beta x will be equal to who? Beta x will be equal to who? Beta x will be equal to who? Great, great. Thank you so much. Thank you so much. So my beta x here, my beta x, this is how my beta x will be equal to beta. It's the covariance between the portfolio and the market. So this is covariance between the portfolio and the market, all over the standard deviation of the market done what here? Squared. All over the standard deviation of the market squared. So here I can see, first of all, a low-hanging fruit. A low-hanging fruit, which is the standard deviation. So go ahead and give us the standard deviation of the market. Go ahead and give us the standard deviation of the market. Go ahead and give us the standard deviation of the market. So standard deviation of the market, standard deviation of the market, Captain Mulinge, I've always been thinking that that captain is not genuine. Now today I can see you in full uniform. Congratulations. So this class is a special one. We have a captain, right? And then we have a nurse, right? That's what we call risk diversification. That's actually a portfolio, So portfolio is all about management of what here risks, doing different things. And I even told you, when it even comes to marriage, don't marry a fellow accountant. Are you crazy? Right? What if the accounting industry, in this case here, is in recession? Diversify. Marry a primary school teacher. We shall overcome, right? We shall overcome. We need to know how to, I'm a farmer. You need to diversify. Life needs a lot of diversification. Like myself, I'm married to a vet, they call it veterinary, yeah, but there's another pronunciation like that. Something very different. So although my wife came again and did another CPA, but at least there are things I talk about in the house and she wonders. She thinks that she married a genius, right? Like if you have a primary school teacher and then you say debit credit, or even write this kind of a formula, that great lady will think that she has a genius for her husband, which is very good, Not accountant, debit. No. We feel that we must diversify. So then how do we get the standard deviation? This is a very easy thing. Never be cheated. Portfolio theory is the cheapest, is the easiest topic. Because when you talk of standard deviation, it is the difference between two types of returns. Deviation means subtraction. So we have here returns of the market minus the expected returns of the market. And then we do what here somebody will square. Remember that this has to be in terms of what here, if you remember, this deviation squared must always be compared with probability. And then what do? There must be a summation there. It cannot be called a standardized deviation if it doesn't have what here, if it doesn't have a square root. If it doesn't have a square root, then that is not really standard deviation. Standard deviation of the market. So returns of the market minus expected returns of the market. And then we come and take what here? Square root. Don't forget to square. Thank you very much. Now, ladies and gentlemen, thank you very much. We don't have probabilities. So after I write this formula, I'll come very fast and realize, hey, there are no probabilities. What very many students will do once they realize that there are no probabilities, they'll stop doing the question. And then they'll call me after class. Mwalimu, we are so happy we are going to get free marks. Then I ask them why. And there was an error in the question. They never gave us probabilities. And now, because it will be near Christmas festivities, I will not want to mess with your Christmas moods. So I'll confirm to you and tell you that, you know what? For sure, that was what you had to make you happy, right? So the gentlemen, here there are no probabilities. So if there are no probabilities, then straight away, I will have to look for another way of getting an average yes. So I'll come under remove this probability, and then I divide with what we call n. But now you realize, when I estimated the returns, average returns, I lost what we call a degree of freedom. I lost a degree of freedom. Whenever you have an estimate, you lose a degree of freedom from your population, So we don't want to go into that because we are not statisticians here. What we want to know, ladies and gentlemen, here is this fact here. What we want to know is that always for standard deviation of the market, we will come down here and subtract what here 1. We'll come down here and subtract 1 always. Listen to me. We are told that if the sample is large, if, for example, you had these states here being 30 and above, if the sample is large, then you will not subtract that 1. But now let me ask you a question. Is there a possibility that this examiner will deny you probability, and then he goes ahead to give you a large sample? Is there a possibility that he denies you probability here, and then he goes ahead to give you like 40 items? Is he crazy? That working cannot be there. And that is why I normally tell my students here, ladies and gentlemen, anytime you don't have probability, you can even cram these things. Stop talking about large samples and small samples. Anytime you have a situation where we don't have probabilities, for standard deviation calculations, for covariance calculations, that down here, we shall always be subtracting what there, we shall always be subtracting 1. We shall always be subtracting what there, 1. We shall always be subtracting 1. We shall always be subtracting 1. We shall always be subtracting 1 like that. Great. Now, ladies and gentlemen, please listen and listen to me very well. What I'll need to do is to come here and now get a numerator working for this. I would want to squeeze this working here. So we have here returns of the market minus expected returns of the market squared. This is what I want. I don't have probability. So I'll come and create a column here. Returns of the market, I can see them here. We have 3, 7, 5, minus. Is there somebody who can remind Mwalim what the expected return of the market was? We had obtained it somewhere. Expected return of the market, we had obtained it somewhere. Gladys tells me 5, 5, 5. And now remember that if it's 5, it doesn't keep on dancing. If it's 5, it's going to be like that throughout. So if it's 5, it's going to be like that throughout. So this is it. So please come and give me this figure. Remember, it is RM minus ZRM. You square first, and then summation will come in later. So please give me this figure very fast. So 3 minus 5, whatever we get, we square. 3 minus 5, whatever we get, we square. It must be 4 positive. Because you see, this will be minus 2. Minus 2 times minus 2. Minus 2 times minus 2 is positive 4 like that. And then we have 7 minus 5. Again, whatever we get squared. 7 minus 5 squared gives me what here, somebody? This gives me again 4. Of course, this is 0. So 4 plus 0, this gives me 8. So that means that I've already taken care of the numerator. Because the numerator, they want me first of all to sum this deviation square. Right? So whatever I have here is the numerator, which is 8 divided by n. N in this particular case is how much? N, number of states. How many states do we have? We have 3, right? We have 3. So then this will be 3 minus 1. So 8 over 2. So this is 8 over 2. 8 over 2, which is 4. And then I want the square root of 4. I want the square root of yes. And then it's making a response as to the n, which is 3. As the n, which is 3 here. So in this case here, we have, ladies and gentlemen, the standard deviation of the market here is 2. The standard deviation of the market is 2. So if you have got some highlighter, I was told to be using a pink highlighter. If you've got a pink highlighter, you can highlight this standard deviation of the market, and the answer to simply highlight them nicely. Standard deviation of the market and these two. These are quite pivotal to me. Now we have my own asking a very good question. Why do we divide by n minus 1? It's because of the degree of freedom which is lost when you got an average up there. But my own, if we go back into that science, we shall not be able to move. For me, if I were you, there are things to simply cram. If I were you, my own, what I would have mastered is that whenever we are getting the standard deviation of the market, in a situation where there are no probabilities, or standard deviation of whatever, in a situation where there are no probabilities, I shall always divide down there to average by n minus 1. N minus 1. That happens to standard deviation and the covariance only. Standard deviation and the covariance always divide by what here? N minus 1 to average in situations where we don't have probabilities. So is that clear? 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 Great. To mean those, good questions here. To mean those who don't minus 1, if you don't minus 1 as an examiner, if I get yourself doing this kind of a question and not subtracting 1, you get 0. You get 0. 0. You get 0. You get 0. You get 0. You get 0. So what have we said, ladies and gentlemen? We've said here, if it's not a deviation of the market, always divide by what here somebody n minus 1. Divided by n minus 1. Divided by n minus 1. When we don't have what here probabilities like that. So then I've been able to get the standard deviation of the market. So the next thing will be for me to give them the covariance. Covariance, 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 covariance. So covariance between X and M. Is there anybody who will be able to give us this covariance now? The covariance formula, oh yeah. Is there anybody who can give me the covariance formula? Covariance between X and M for us to be able to get the beta now. For us to be able to get this beta, is there anybody who can give us the covariance formula? Let me see a little bit. Let me wait a little bit for somebody to give me the covariance between X and M. No, thank you, but you're confusing my own there. Sorry, you're confusing, but we shall overcome. We shall overcome. You're confusing this with coefficient of variation. They're different. They're different. This is covariance. This is covariance. Covariance. Yes, I can see HO.com. Yes, they're telling me that covariance, it will be the deviation of X now, deviation of X times deviation of M times then I remember that probabilities are not there. They are not there. If they are not there, then automatically I have to come and sum whatever I have there, and then I divide this with what is somebody n minus 1 to average. Why did we not minus when calculating for ERM and ERX? Good question. ERM and the ERX averages, that is where we begin from. The first estimate in statistics, you don't subtract that n minus 1. The first estimate, you don't do that subtraction, remember. We don't do that subtraction. For the average, you divide with n. And then in any other subsequent now formula, you have to adjust that one from n. Subsequent formulas, that is standard deviation, covariances, and any other subsequent formulas, those ones you must subtract what here? 1 from n. Don't worry, you get used to these. These are simple things. Simple things. Abracadabra, deviation of X, what do we have here? You know, when we talk of deviation of X, this means we talk over Rx minus ERX. And then deviation of M, and what we have here, it is Rm minus ERM. And then whatever we shall get, we shall sum. We shall sum. And then, of course, ultimately, ladies and gentlemen, we shall come and divide this with what here, n minus 1, later on, n minus 1. Then, ladies and gentlemen, I would want to come here and basically do what here, arrange this data. Like when we talk over Rx, it's here. Returns, actual returns of X here, we have 15, we have 8, 7. Is there anybody who can remind us what ERX? Here, N stands for these states, the numbers. Number of states, for example, number of returns, 3. Yeah. So is there anybody who is able to remind us? 10 years. So abracadabra, remember 10 will not keep on fluctuating. So 10, 10, 10, 10. And then you come and put this in a bracket. Then we have RM. So RM, what do we have here for RM? It is 375 minus, minus, minus. How about the expected return of M? You guys have given me the expected return of M. You've given me the expected return of M. It was 5. Thank you so much. So we have here 5, 5, 5 like that. So remember that this summation is only touching here. So first of all, you have to get these separately. You add them. Don't think that you're going to divide each one of them with n minus 1. No. This is very, actually supposed to be down. It's very dependent. It's very dependent. So come and take your calculator and say open bracket, 15 minus 10 in close bracket times open bracket, 3 minus 5 you close. You tell me the first answer. Tell me the first answer. Is there somebody who is able to give us the first answer here? John Mudiani, my friend, the David, they're telling me, the first one is negative 10. Thank you so much. Thank you so much. So please go to the second one now. Go to the second one now. So the second one, I'm being told is 4 by Sharon, David, and Nanga. 4. Of course, this one I don't want to give you the answer. This one is what here is 0. It's 0. And then I'll come and add them up. So could you kindly give me the summation here? Give me the summation here. Give me the summation here. So then this one will give me negative who? Negative 14. Are you sure? That's a lie. That is a lie. That is a lie because you are summing. Use your calculator. Minus 10 plus 4. Minus 10 plus 4. Minus 10 plus 4. Use your calculator. That will be minus 6. I'm not so sure, but unless you tell me that this is negative 4. Is this negative 4? Is this negative 4? Is this negative 4? Is this negative 4 or just 4? Is it negative 4? Is it negative 4? Is it negative 4? This one I'm being told is negative 4. So if it's negative 4, if this is negative 4, then it means that this has to be negative 14. I'm not so sure. I don't have a calculator. I don't have a calculator. So are we in agreement that the answer, the correct answer is negative 14? Are we in agreement? Are we in agreement that the correct answer is negative 14? Are we in agreement? Are we in agreement? Yes. Thank you so much. So please, again, I'm repeating this formula. This formula is so close to my heart. This formula is very important. It's a very important formula. This is a very important formula. This is a very important formula. The formula of getting covariance. The formula of getting covariance between X and M. The formula of getting covariance between X and M. What have we said? So covariance between X and M, you said it's deviation X multiplied by deviation M, like that. And then we shall come and divide everything with N minus 1, like that. And then you guys have told me that the denominator here, is negative 14. And then our N was those 3 states. Then N was the 3 states. N was the 3 states. The 3 states. So 3 minus 1. 3 minus 1, and that gives us negative 14 all over 2, which gives us negative 7. Which gives us negative 7. So once we get negative 7, could you kindly give me the square root of negative 7? Give me the square root. And I can see you trying to look for that square root. And yet the formula of covariance does not have any square root anywhere. Does not have any square root. I know that's what the mistake. I'm so sure there must be somebody, and I'm able to see you from here with my camera. I'm able to see you. I'm so sure there must have been somebody who tried getting negative 7 and they told them math error. Math error. Anyway, in the covariance calculation, there is nothing like squaring. There is nothing like square root. Nothing. So are we together? Are we together? Are we together as regards the covariance? Yes. So please don't forget what they want us to calculate. What they wanted us to calculate is beta of security X, which will be equal to covariance between X and M all over the standard deviation of the market squared. The covariance is what you guys have given me as negative X. The standard deviation of the market was 2, but remember this 2 has to be squared. The 2 has to be squared like that. So is there somebody who can give me? Is there somebody who can give me this beta of x, is there anybody who can give me the beta of x? Minus 7 over 4. Minus 7 over 4. Abracadabra gives me what figure? Minus 1.75. So here we have minus 1.75 like that. Minus 1.75 like that. That is a very important step for us. We got expected returns. We got standard deviation of the market squared. We have gotten covariance, and ultimately we have gotten beta. Now, once I have all those metrics, now I can punch hard the CAPM returns. The CAPM returns. I'll punch hard the CAPM returns. That formula. So give us the CAPM returns of what here? Of x. Give us the CAPM returns of x. Give us the CAPM returns of x. Give us the CAPM returns of x. Give us here the CAPM returns of x. Repeat again the formula. Of course, you guys know the formula. We must start with risk-free plus ERM minus risk-free. And then outside here we have BS, but remember the name of our security here is BX. The name of our security here is BX. So could you kindly go ahead and remind Mwalimu, are you able to remember what our RF was? Is there anybody who is able to remember what our RF was? Okay. Just a moment, I can see some figure here. Jacqueline, was standard deviation 2 or 2.828? I remember very well that the variance of the market was 4 exactly. And then when we took a square root of 4, we got 2. We got 2. Can somebody, in this case here, for the interest, for the sake of Jacqueline, is there someone who can take a screenshot of the standard deviation of the market, that formula? And the answer, you can even circle that answer for us. And then you throw that particular photo on WhatsApp or our WhatsApp group. Can somebody do that? And Jacqueline should go to confirm whether she's gotten a good Samaritan, so that she can see where she went from, because it's like she got 2.822, 2.8 something. Great. So a good Samaritan, very fast. You know, an accountant is really good in agility. We are agile. We are agile. We are never flexible. We are never rigid. We are very flexible. We are very flexible. Actually, you are the only accountants I normally see making a lot of noise in the group. I don't know why. This must be a special group. No, accountants are supposed to be very agile, understanding very fast. You know that this Mwalimu has got a lot of interests for you people. I not want you guys to fail. And you have an obligation of liking your teacher. You must like you in this space. You must like it for you to pass. If you hate this space, you will fail. Right? So you must put yourself in a way that you will like Mwalimu, whether you like it or not. So making a lot of noise really brings a lot of negative energy in the group. You have videos, etc. Don't make noise. Don't make noise. We shall never make noise again. Never, never, never. Because if you make noise and Mwalimu has got some secret, do you think the moment of that bad blood and with the teacher, do you think the teacher can give you? No, I'm joking. I'm joking. So risk-free. Give me the risk-free rate here. The risk-free. The risk-free, we had written the risk-free rate here. The noise, a lot of noise should be made here, asking questions here, not on WhatsApp. WhatsApp, we are there to help each other. You shall not take your Mwalimu to DCI, for example. Why now? We don't use that language here, right? So what do we have here? Somebody risk-free, risk-free. Somebody must have forgotten the risk-free rate of return. Oh, 3%. So remember all the other figures are in form of percentage. So then this has to be 3. You ignore the percentage. So 3 plus. How about expected return of the market? Do we have the expected return of the market? Oh, yes. You guys had given me the expected return of the market was 5 minus risk-free, 3 multiplied by beta of x. Beta of x, beta of x. We have just computed beta of x. Is there someone who can remind us what the beta of x is? Minus 7 over 4. It was 1 point something, isn't it? Minus 1.75. Minus 1.75. Now come here and use polymers. So this is 3 plus. What is this? This gives me minus 2. Not minus 2, but positive 2. Positive 2 times negative 1.75. Then the answer here, the CAPM returns the CAPM returns, ladies and gentlemen, will end up giving me a negative answer, which does not make sense. Of course, it's because I did what here? It's because I got this answer from my head, from my head. So that is a very important concept that I wanted you to learn. Very important concept that I wanted you to learn, which I would want you to see how it has been tested in the past. How it has been tested in the past. It has been tested several times. Not once, not twice, not thrice. It has been tested several times. Several, not once, not twice, not thrice. Several times. Several times. Where they don't give you probabilities. Where they don't give you probabilities, and then they expect you to work out magic. Then they expect you to work out magic. For example, the November 2016 question 2 question. Why was standard deviation for market taken alone for calculating beta X? Good question. How did you get the 3% was given, James Moore, 3%. Risk-free was given in the question. The risk-free rate of return was given in the question. And then my own question, I'll be able to answer my own question, ladies and gentlemen, here. Why do we calculate just beta? Why was that deviation for market? Yes, it's because of the formula. Look at beta of X. Look at beta of X. Beta of any security, my own. If you look at beta of any security, to get beta of a security, we take the covariance between the security and the market all over the standard deviation of the market. You see, we don't have a S. Is the standard deviation of the market what here? Square? Square. It is the standard deviation of the market square. It is the standard deviation of the market square. So have they gotten November 2016 question number 2? November 2016 question number 2, have they gotten that question? It's on page number 55 of the revision kit. 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 They are not telling you whether they have gotten it. Thank you, Moru, Jacqueline, James, Moa, like Moa University, Miami. Yes, great. And then remember for portfolio, because it has got many formulas, you must, in this case here, for example, after class, get like a blank page and try to remind yourself by writing op-ed. Like, what is the formula of a CAPM returns? What is the formula of beta of the whatever? When we say beta of the market equals 1, try to remember, like, you must write all those formulas op-ed and then try to think about them. When we are sleeping, you must also try to think about what here, about our studies. About our studies. Don't be thinking about problems most of the times, no. Don't be thinking about money alone, no. Also get some time to do some self-reflection. Even when you are sleeping, you say, what was the beta or the security formula? I'm able to see it from my inner eye. It's covariance between that security and the market. Or over the standard deviation of the market, what is square? Square. That will be able to remember. Very important. Very important. A captain, was it from, it wasn't from any year. Imaginary, yes. Imaginary example. Which year do you see? This is November 2016. Question number 2. 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 Let me write on the board. Let me write on the board. Actually, if I were you and I've gotten that question, what I'll do, if I have that past paper, because I know some of us are so nice at getting these things, what I'll do is to simply throw it to our WhatsApp group. Then I take a screenshot, throw the question to our WhatsApp group. I want to do part B. Moses Mapesa, November 2016. November 2016. Question number 2. November 2016. Question number 2. Moses Mapesa is in the process of evaluating investment in 2 companies whose percentage returns in the last 10 years are as follows. See, then we have years 1 to 10. Then we have FS limited percentage. Then we have got SN limited percentage. So they want us to do something very easy. They want us to give them the correlation coefficient of the company's returns, the correlation coefficient of the company's returns. What already have we done this question? Oh, have we done this question? Have we done this question? Somebody is telling me that you have done the question. Somebody is telling me you have done the question. Although I get where Levi is coming from, chances are it is in the video. Chances are it is in the video. 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 So, okay, YouTube video. So I don't know what will be the best way forward. Yeah, should I repeat it here, or should we give our students an opportunity of watching that video? Should we repeat it here? Assignment, Assignment. We do it here live, We do it here live. Yeah, then let's just do it. Let's do it. But of course, as we get along, also students should be able to get, you need to do this. Watch these videos. We need to watch these videos at the end of the day. We need to watch them. We need to watch these videos. We need to watch these videos. These videos are yours. We should only be coming here. For example, I should be coming here and trying to show you how do we harvest these low-hanging fruits. Number one. Number two, when you watch that video, what was the most technical thing there? Maybe how to get this out. When we discuss like that, I discovered my students really appreciate these concepts very well. But because I'm not giving you that, then I would rather we do what here, as many you can see, many students have said, we do what here, we do the question. David, you're not telling me to repeat David. David, just tell me to do the question, because repetition means that you had watched. I'm so sure, David, you haven't watched this video. 100% sure. But again, I can't blame you guys, because accountants are very busy at their workplace, especially now that we are at the end of the month, during the what we call closing process, payroll, etc., end of the month issues. But you see, we still have to pass. Still have to pass. Abracadabra, nitakuja hapa nisimamishe hii namna hii. Niseme here abracadabra is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Niseme hapa F alone, I don't have to say FS. F alone, so returns of F. That can confuse us. F, returns of F is pretty confusing. Let's write on F. And then we have S in form of percentages. These are returns, oh yeah. These are returns, oh yeah. These are returns, oh yeah. Now what we'll do, let's just call it FS, and then the way it is called there, SN. So that I can put returns here. Returns like that. Abracadabra, the first one is 37. The second one is 24 minus 7. Then we have 6, 18. Then we have 32. 32. We have minus 5. We have 21. We have 18. We have 6. And then we have got returns from SN Limited. We have 32. Oh, we have 29. We have minus 12. We have 1. Now we have 15. We have 30. We have 0. We have 18, 27. Then we have 10. If you give me this kind of a thing, because it doesn't have probabilities, the first thing I'll do is to get the total. The first thing I'll have to do is to get the total. It's like is my board clearing? Is my board clear? 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 It is clear, but you want to see the top here, isn't it? You want to see the top here. The top is what is missing, right? Top is what is missing, but it's clear. Must be very clear. Must be very clear. Must be very clear. Must be very clear. Very clear. I'm proud of this. I'm very proud of this. And now I believe you're able to see the top now. I believe you're able to see the top now. Great. Not yet. Not yet. Not yet. But again, if I make them very small, international disaster, you will not be able to enjoy the border anymore. It will become an international disaster. become an international disaster, but I believe now it's okay. Now we should not go below that. We should not go below that. Better. Yes, thank you very much. So they're telling me that returns over Fs is 150. When you add that, when you add is 150. How about returns of Sn? Returns of Sn, is there somebody who is able to do this abracadabra very fast and then give us the returns of Sn? So returns of Sn, we have 150. So could you kindly come and average this? Could you kindly come and give me the expected returns of Fs? Remember now, this will be the total returns of Fs to divide with n. We are averaging. We are averaging, so we shall come and take 150 that you guys have given me, divided by the number of years, divided by n alone, which gives me 15. And then we have expected returns of Sn. So this will be summation over Rsn over what here somebody, and again 150 over 10, which gives me 15. The very worst mistake you can ever do, ladies and gentlemen, is to start subtracting, making the -1 adjustment E, expected return. We don't make the -1 adjustment. Don't ask me why, but we don't make that -1 adjustment. We don't make it here. 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 Great, 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 great. So, ladies and gentlemen, what I would expect then you guys to do very fast, please go ahead and give me the standard deviation of the market here. Go ahead and give me the standard deviation of the market. The standard deviation of the market. Go ahead and give me the standard deviation of the market. Go ahead and give me the standard deviation of the market. Go ahead and give me the standard deviation of the market. Okay, so we have a student called a T there who does not understand why we are not subtracting 1 from n. Yes, I think whatever Sharon has told you makes a lot of sense. You may think she's harsh, but that is a very good explanation. That is the formula of what ER, kama hakuna probability. Kama hakuna probability. Haina explanation, shika hivo, shika hivo. Ukisikia ER whatever, so long as it's expected returns we're getting, always we shall divide with what here somebody n. If it is the deviations, like the standard deviation, like the covariance, those ones you must divide with what here somebody n-1. N-1. It's like looking for mean, yes. You're looking for the mean, yes. You're looking for the mean. So standard deviation of the market, abracadabra formula. It is standard deviation of the market equals returns of the market minus expected returns of the market. These has to be in terms of sum of what is squares times probability, but probabilities are not there. So divide this by what? Because it's a deviation, I must come and divide this with n-1. Remember, this summation is only touching here. So come very fast, abracadabra, then you put what's up there? You put a bra, or rather a square, a square root. You put a square root. Haya, haya, haya. Lakini sasa hapa hakuna market. Mimi naangalia CAPM sana. Hakuna market hapa. What do they want us to calculate? What do they want us to calculate? Hapa there is no market, by the way. There is no market, by the way. Here they want us to calculate the correlation between the two. So can somebody in this case here give me the way forward? The formula. How do I calculate the correlation between F and S? Is there somebody who knows the formula? How do we calculate the correlation between F and S? How do we calculate the correlation between F and S? This is not a beta question. It's not a CAPM question. So what I would want you to do, simply go there and put a wrong. Say Mwalimu is wrong. Mwalimu is wrong. Say Mwalimu is wrong. Say Mwalimu is wrong. They never asked about us. They never asked us about CAPM. They've asked us about correlation, coefficient. They've asked about correlation. I know this for sure. This is quite a very simple thing. But to get the correlation coefficient, which is designated as R, between Fs and Sn, I will come and take the covariance between Fs and Sn all over the standard deviation of Fs. Standard deviation of what here, somebody? Sn. Covariance between Fs and Sn all over the respective standard deviations of my own. Now here we are using the standard deviations of the two securities. Of the two securities, because we don't have market anyway here. Right? Thank you very much. So please come and give us the covariance. The covariance between Fs and Sn. The covariance between Fs and Fn. How do we get this covariance? I know the formula. I know it's about the deviations of the two. So here I will talk about RFS minus E, RFS. And then I put this in brackets. And then I'll come and say here, we have this other security, which will be RSN minus E, RSN times, I wish I had the probabilities. There are no probabilities. So I need to come and sum here, and then I'll divide everything with N minus 1. I love this. I'll divide everything by N minus 1. So then, could you kindly, first of all, write down this formula and put it down in pink color, highlight it, have your highlighter passing through it. And once you finish writing it, could you kindly put a thumbs up on your Zoom there, on your Zoom there, put a thumbs up on your Zoom there, put a thumbs up on your Zoom there. Covariance between Fs and Sn. Great. Already have written that. So then I would want us to organize, ladies and gentlemen, and have this denominator. Let's have this denominator, or the numerator here. Let's have the numerator where we have RS minus ERS. RFS minus ERFS. And then we have RSN minus ERSN. Let's have, first of all, this down there. So abracadabra, do we have RFS? These are the actuals, yes. So we have here 37, 24 minus 7, 6, 18, 32 minus 5, 21, 18, and then we have 6 minus. ERF, the expected return of Fs. Expected return of Fs. Expected return of Fs, I remember we had to compute it somewhere there, it was 15. And this one here does not keep on fluctuating. This 15 will be like that constantly. The 15 will be like that constantly, like that. The 15 will be like that constantly, like that. The 15 will be like that constantly, like that. Open brackets, open brackets, open brackets, open brackets. And then we have got RSN. RSN, where is RSN here? We have 32. 32. We have 29 minus 12. We have 1, 15. We have 30, we have 0, we have 18, 27, 10, minus, and then we have the ERSN, expected return of SN. Expected return of SN, you guys gave me again 15, 15, 15, 15, 15, 15 like that, 15, 15, 15, 15, 15. Then from there now, I'm so lucky because my book is so nice. I will come, ladies and gentlemen, here and rub the ears for you guys to give me the numbers now. For you guys to give me the numbers now. For you guys to give me the numbers. 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 So open bracket here, 37 minus 15 close times. Open bracket here, 32 minus 15 close. Tell us equals. Tell us equals. The first one. The first one. Is there some good boy child who can give me the figures here? Already Sharon has the total, right? Is that the total, Sharon? Is that the total, Sharon? Right, and Kubwa sana, 1874. Is that the total? 370. No, let's go slowly. Please give me the first one. Just stay there, open bracket 37 minus 15 close times open bracket 32 minus 15. Give me the first answer. Please, Kichuan says 374. 374. And then we go to the second one. The second one, we have open brackets 24 minus 15 in close times. Open brackets 29 minus 15 in close. You give me the second figure. According to Eli, 126. So how about the third one? How about the third one? 594. 594. From there we go to the fourth one. Life is good. Life is good. The fourth one now. 126. The fifth one. We're almost there. The fifth one is 0. How I wish all of them could be 0. To have made my work very easy. So we go to the sixth one. The sixth one, I'm being given 255. 255. And then we go to the seventh one, 300. The seventh one is 300. And then we go to the eighth one. The eighth one is how much? The eighth one is 18. 18, eh? 18. Then we go to the ninth one. I mean the second last. When I put the second last, it looks nice. Looks nice. So in this case here we have the ninth one. The ninth one is 30 what here is 36. And then the very last one, which is the 10th one, inakuja inakuwa ngapi? Inakuja inakuwa ngapi? The last one now, inakuja inakuwa ngapi? 45. And then now give us the total. Give us the total. 1874, the year that I was born. 1874. So 1874 is what will come and put here. 1874 is your total here. So we have here 1874 over n. N umesema ni 10. 10 years. So then we have 10 minus 1. 10 minus 1 gives me 9. So then what is 1874 divided by 9? 1874 divided by 9. Is there somebody who is able to give us an answer here? Sharon tells me it is 208.22. 208.22, like that. 208.22. You underline like that. 208.22. So abracadabra. From there now we can look for the standard deviations of the two securities. We start with the standard deviation of FS. We start with the standard deviation of what here? The standard deviation of FS. The standard deviation of what here? FS. We start with the standard deviation of FS. So is there somebody who can, I mean, this is the easiest thing ever. It's about the terms of FS. So we have the terms of FS minus expected returns of FS. We square this. No probability, so it means I'll have to sum, and then I talk of what here n minus 1, and then whatever we'll get, I'll come and have it the square root like that. So abracadabra, what do I have here? I have to start with the numerator. Fortunately, I have the numerator here. It is here. So like the first one, if I'm the one doing this, this becomes very easy. I don't even have to write this down really, but for the sake of your revision, so like the first one is 37 minus 15. Then I square it, I get an answer. The way they are here, 24 minus 15, I square it. 24 minus 15. I square it. I get an answer. Then we have here minus 7 minus 15. I make sure they are inside brackets. I make sure they are inside brackets. And then I'll be able to do that blah, 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 until I come and get the top of here. Blah, 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 until I get the top of here. So you do like that for the whole. I don't know whether you guys are able to follow what I'm talking about. Are you able to follow what I'm talking about? Remember the square root and the n minus 1 will be the last thing to be done. Right? Are you able to follow what I'm talking about there when getting the standard deviation of FS? Standard deviation of FS. Standard deviation of FS. Are they able to follow really? Are they able to follow? Are they able to follow? They are not able to follow. Most of them are not responding, meaning they are not following. Meaning they are not following, meaning, okay. So then please do like that until you get the total down here. Please, everybody must do that until you get the total. Today I have to get answers from all of you. Today I must get answers from all of you. From all of you today, I'm getting answers. I'm getting answers today from all of you. So please confirm whether all of us are able to get that 484. Sharon says, no, it can't be 484. According to Sharon Kendi, it is 1954. It is 1954. Sharon, she's getting 1954. Thank you very much. I love, in this case, a situation where students get out of their way. It seems this 1954 is getting traction. Is getting popularity. The 1954 is getting popularity. Omar, 1954, I believe that is an error. Or 484 is for the first one. Thank you so much for that clarification. So I expect someone to get for all of them. For all of them. So 1954. So here we have 1954. Here we have 1954 divided by, I know you know 9. And then whatever answer I will get a square root. So say 1954 divided by 9 equals, whatever answer we get, we say square root. We say square root. Whatever answer we get, we say square root. Whatever answer we get, we say square root. So Sharon tells me it is 14.73. Sharon tells me that this is 14.73. 14.73. 14.73. 14.73. 14.73. Thank you, and thank you so much. So then could you kindly do me a favor? Out of, in this case here, your concept of understanding, point of view, I would want someone to go ahead and calculate for me the standard deviation of the second security. Please calculate for me the standard deviation of the second security. How do we get the standard deviation of the second security? How do we get the standard deviation of the second security? The standard deviation of Sn. Let me see whether there is anybody who will be able to write it correctly. Second security, they are calling it Sn. Let's see whether there is anybody who will be able to write that formula correctly. Let's see whether there is anybody who will be able to write that formula correctly. Standard deviation of Sn. 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 What do we have there? Formula. This is a very easy one. I know it's about the two types of returns of Sn. So I know it is RSN minus ERSN. And then we do what here, somebody will square. There are no probabilities, so n minus 1. But of course, I have to sum first before I divide like that. And then, of course, there is a square root like that. And then I'll come and create a column for the numerator. I will say RSN minus ERSN. And then we have here squared like that. Squared like that. And then we'll come and do what is in Germany. Yeah. Now straight out to get these numbers. I can take What I can, if I'm a bright student, I pick them from here. But if I want, I can also pick the actuals here. Abracadabra, we have 32, we have 29, we have minus 12, we have 1, 15, 30, 0, 18, 27, 10. You say minus. Could you kindly remind Mwalimu what ERSN was? Is there anybody who is able to remind Mwalimu what ERSN? Expected return over SN. Expected return of SN, Beshashiga na 15. Hiyo lugha najua Sharon kiingia uelewe. Hiyo lugha ni ngumu. Hiyo lugha ni Bantu. Kama wewe si Bantu, basi ni ngumu sana. Hiyo ni Bantu. Square, like that, abracadabra. Then what do we have here? Is there someone who is able to do and then give me the total sincerely? Aha, I can see what Jacqueline is saying. Yes, Jacqueline, and I say my total is 2038. Unfortunately, the students who are not giving me figures at all. I would prefer a situation where I'm getting figures from every student. Where I get figures from every student. Thank you very much. So after that, then I should be able to come now and plug in. So I need to come and talk of 2038 divided by n minus 1. So n minus 1, that is 9. N minus 1 is 9. N minus 1 is 9. N minus 1 is 9. So I talk of 2038 divided by 9. Whatever answer I get the square root. I take the square root. Whatever answer I get, I take the square root. Whatever answer I get, I take the square root. Whatever answer I get, I take the square root. 2038 divided by 9. 2038 divided by 9. And then you take the square root. We are getting 15 point what here? 05. They are getting 15.05. Thanks, Joyce. Thanks, D. Priscilla CC. Evelina Tieno. Karinga. 15.048. Jacqueline. Thank you so much. So please try to be very active. Try to be very active because it's also very important for Mwalimu to call out your name. Even in your family setup, I mean. If, for example, your people are hearing Mwalimu talking about Karinga, hoo.com, John Muthiani, they may ask you, how comes your name is not being called at all? How comes your name is not being called at all? And then you start fighting with your firstborn daughter. You get out of here. These are why you even next to where I'm studying. And if the fault is yours, you're not giving us figures, you're not asking us questions, you know. You need to be very active. Yes, you must be very active, yes. That's very important, yes. Very important to you. You must be very active here. Yeah. So when I say the final answer, abracadabra, the final answer, what I'm doing for you, when I say 15.0, have you gotten the square root? Have you gotten the 15.048? Have you gotten the square root? Have you gotten the square root? Yes, thank you so much. Now again, abracadabra here. Could you kindly remind Mwalimu the formula of a correlation between two securities? How do we get, let me simplify this first of all. How do we get R between X and Y? How do we get R between X and Y? How do we get R between X and Y? How do we get R between X and Y? So how do we get correlation between, I know this formula like nothing. Correlation, it will be covariance between X, Y, all over standard deviation between the two. All over standard deviation between the two. So when they talk of a correlation between FS and SN, this is very easy. It will be covariance between FS and SN divided by their respective standard deviations. Divided by their respective standard deviations like that. Divided by their respective standard deviations like that. Abracadabra. Fortunately, we got this long time ago. Is there somebody who is able to remind us what covariance between the two securities was? We got a very beautiful figure I remember that beautiful figure. I remember that beautiful figure. 208.22. 208.22 divided by the respective standard deviations. At least I remember the standard deviation of the last one, 15.048 times this one here times this one here. So 15.048 times what we have here. Nipatie ingine, Jacqueline ananiambia ingine kuna kuja 14.75. We have in this case here D giving me 14. It doesn't matter really, 14.73 and 14. So the last one, I'm being given an answer. I'm being given an answer which is 0.what here? 0.94, which is 0.94. 0.94. So this tells me that R in this case is 0.94, which gives me an 94% relationship, which gives me an 94% relationship, a 94% positive relationship. So this is a very high correlation, 94%, very high correlation. Not good for building a portfolio. The two securities are not good for portfolio formation. That is very high. That's very high. When you are a mirror image of the other, you can't make a very good couple. You can never make a very good couple. Right? And that's why I told you, and gentlemen, the very best thing is to diversify. An accountant, in this case, you're marrying somebody from a very different what you said sector. That's how you will rhyme. Right? So even working, if possible, if you have your own capital, your husband has got his own capital, let you guys do different businesses, right? Because we would want in this case situations where the correlation is -1. -1 is perfect, where this person is like that, right? We need to know how to accommodate each other's what are the differences. But ladies and gentlemen, the moment we reach a level where we become like pastors, right? That's a fake life. But baby, what do we have for breakfast? And then the lady comes, the whole crowd. Perfect relationships don't go very far away, right? That's international water disaster. You're walking around holding each other hands like that. International water disaster. International disaster, like Mutua, the governor, former governor of Machakos. We shall overcome. So in this case, ladies and gentlemen, this is very high. Why? Because we want to diversify our returns. We want to diversify our what here, our risk. So if we have got securities that mirror each other, like perfect relationships, mirror each other, it means that when the price of one security is up there, the price of the other security is also up there, because they are walking together in the same direction, holding hands. Right? And I would rather have situations where if I'm building a portfolio, when the returns of one security is up there, the returns of the other one should be up there, or rather down there, right? So that it's a swinging. When one is up, the other one. That's how we diversify our risk, 100%. So the optimal one, if possible, R, where we have optimality in terms of forming, building an optimal portfolio, our R should be minus what? -1. What we shall be calling a perfect negative correlation. A perfect negative correlation. So we shall overcome. We shall be meeting in this case here again on Sunday. But before we meet, what should we do? I would want to appoint somebody who will be able to assist in us.